Oklahoma, and just wanted to tell you it's an honor to come to you to welcome you to the class. This is the Advanced Diagnostics. We are going to be running about four, like Elaine said, about 4 classes, and they're going to be progressive classes. So each one is 45, 50 minutes long, things like that. And we are going to look at some of the advanced things that we have seen and heard about in the past on the IDS product, and go through some scenarios and things like that. So a little bit different format than what we've seen in the past. We will be, again, this is a growing webinar class. So again, I don't know how many slides we'll get through today, but we'll look forward to seeing you next time also. Just kind of a little teaser, a little trailer type thing. But again, welcome to the Series 1 Advanced Diagnostics class. First off, I just want to thank you because, again, this is a different format. We may not be able to get to this screen this morning, and I just wanted to give you my phone number and also my email address. And I tell you, thank you for your time spending with us today for this class. Talk a little bit about technical support, and on the left-hand side, got 3 names listed here: Alfredo, Omar, and Ryan. Those particular guys are sitting there in Fort Lauderdale, Florida, waiting for your phone call. One of the reasons that I wanted to share your name, I just wanted to allow you to not only know their name, but also when you talk with them, remember their name. Several reasons about that. It's a personal thing. They are there to help you. They are Bosch employees, and they do a really good job trying to get you off the bucket back into the truck, going to your next job type scenario. So the 800 number is there. You're going to go through the first line company. You'll need model number, serial number, things like that to get you involved in the process of going toward the tech support guys. You'll get a case number. Each of those pieces of equipment is tied to a serial number that's tied to a case number. That case number will always be registered with that particular product. So literally all you would have to do is remember the case number from here on out, and it will automatically populate the model number and serial number. Over on the right-hand side, you'll see our corporate websites. You'll see the program website. You'll see the Academy website. Each one of these webinars is going to have a little quiz tied to it. That quiz will be allowing you to go through there to kind of test what you have learned and remembered and whatnot and that kind of thing. Hopefully you're capable of taking some notes down today. Again, we are going to be covering some of the things that have been talked about, but maybe even in a brief type situation. If you want to grow your business, the ABC program is a very good way to grow your business, to allow Mrs. Jones to find you on the locator, making sure that you register your product, getting that an additional year of warranty with that registered product. And it's just a great way to allow Mrs. Jones to find you when she's looking for a heat pump or an air conditioner or a gas heater or a package unit, things like that. As you register those products, it will grow your business and make you more available to her. All right, so let's get started. Again, this is Series 1. We're looking at the inverter ducted system. This is going to be a comprehensive diagnostic approach. We're going to look at the operation parameters. And guys, we're going to troubleshoot to fix it. We're not going to be throwing parts at things. We're just not going to unroll a bag of parts and say, man, I hope in here in just a little bit we'll find the part that is the problem, and we'll get this unit back up and running. But we're going to troubleshoot this in a sequential manner. And we are again, maybe through tech support help, myself, Rick, or Dave, Ken up in Canada, help there. We will troubleshoot to fix it. And we're going to have some real live scenarios that we're going to be talking with the support team members. And I think that'll be kind of a fun way to end each session. And we're looking forward to that process. So what we're going to do is we're going to look at the IDS 1 versus 2. And when we say IDS 1, that's the 18.5. When we say the 2, that's the 20.5. Little brother, big brother, if you don't mind. And look at some items that are different. First off, the condenser fan motor. The IDS 1 is on the BOVA 36. It's basically a 2-speed fan motor at this time, high and low speed. So we have that old capacitor that we may have felt real familiar with, and we see that. In the BOVA 60, we see that the 1.0 is now grows into an 8-speed ECM motor. And then the 2.0, both the 36 and the 60, have a 10-speed ECM condenser fan motor. Differential in the 1s and the 2s at that point in time, the compressor on the 1.0 is a Mitsubishi. The compressor on the 2.0 is the GMCC branded compressor. Some of the things that are different also, on the BOVA 60 1.0, when the cabinet and you look at the 2 boards that are there, on the 2.0 BOVA 60, it's 1 board. And I've heard about some talk from engineers and product management things about getting that BOVA 1.0 2 board into an e-assembly that basically is a 1 board change out. So that's kind of a neat thing to be looking forward to. It's always better to have a diagnostic approach for 1 board than it is 2. The BOVA 3660 on the 2.0 has 7 new parameters. Those parameters are shown in the data checklist in the IOM. We've got now we have the capability of pushing a parameter button and actually seeing the Hertz rating that is the compressor operational Hertz rating. We couldn't see that with the 1.0. You would have to wait the 20 seconds, let it go back into the LED screen to show you that. Now we can just push a button. So all the way down, you see that we have these different parameters, and I really call this an upgrade. It's a board upgrade so that we can see what's going on with that 2.0 in a greater dimension than we could with the 1.0. Literally, gosh, leaving a whole lot of tools and things in the truck and just having the Phillips screwdriver or the 1/4-inch type chuck to take the cover off and very carefully push the button and see these parameters that are going on inside the 2.0. So I understand that if you knew the sequence of operation and you understood that sequence of operation, it takes you to another level of troubleshooting. Chances are you could probably fix anything if you knew the process of how it's supposed to get its electrical current, how it's supposed to work. Is it a normally closed relay? Is it normally open relay? All of that things, if we knew the sequence of operation, we didn't have to guess at it. Not only is it going to allow us to be better technicians, but it's also going to speed us up. And my dad always said, time is money. And so if we can get better quicker, we will be better at the end of the day and hopefully have more time to do what we want to do and more money in the pocket to do what we want to do. So let's learn a little bit about the sequence of operation. What we're going to do is we're going to look at the cooling mode of the 2.0 first. And I've got 3 slides in here that I'm going to apologize one time for. This particular slide is a picture that was taken, and I tried very hard to find a better way to get it to you, but I just can't. And so when we're looking at the cooling mode operation, we're looking at a call from the compressor, or call from the thermostat, the controller, whether it's yours or mine. We're looking for that Y call, and we're going to get that 18 to 28 volts coming out there, and it's going to basically tell our unit to come on in the cooling mode. Look at the left-hand side over here, and you'll see that I have a compressor, an outdoor fan, I have an EEV valve, I have a reversing valve, and I have the PE valve. So all of these 5 different items here are basically in a position of either ready to be worked, ready to have a call, or in the off position. So when I first get my call, my system has 0 hertz rating because there is no call for it. The compressor is stagnant. But notice that my EEV valve is at the 360 position. That particular number is a number that we probably want to remember when we're doing service work and diagnostic on the E valve itself. So that is its stagnant, its off position is 360. Look at my reversing valve, it is off. And so what we're looking at here is a ready now to work piece of equipment. We have L1 and L2 voltage, and we get a call for a compressor to come on. When the compressor comes on, we are up here now in the A, what they call the A hertz rating. If we moved over here to this particular diagram, we see that the A represents right around 38 hertz, whether it's a 2, 3, 4, or 5 ton piece of equipment. So this particular range is going to be 38 hertz on the 2.0. That 38 hertz is going to be there for 1 minute. And what we're looking at here is the progression of what we would call staging, if you don't mind, to a Y1 call. Because it's not like I have a old grandpa type air compressor where when the compressor came on through the contactor, we were on. At that point in time, with that old style, we drew a whole lot of inrush lock rotor amps, and the lights blinked, and everybody knew that the compressor was on because it was painful outside on the concrete pad. This particular system, when this unit starts up, we're at a very, very start low amp draw, basically less than 1.7 amps. So no light blinking, things like that. So take a look at what's happened here. We have a cooling call. My outdoor fan has came on, but you understand that if my outdoor fan comes on and the fan had probably ran for about 30 to 40 seconds prior to the compressor coming on. That is just a logic inside the board. And that fan motor is basically starting at its highest capacity. That 1.03 ton unit, it'll start high. That 2.03 ton unit, it'll start in a higher echelon, and then it will go down to the lowest or a lower echelon when the compressor starts. So here we are, we've got the fan motor started. And what we're going to be doing is we're going to be looking at a increase of fan speed based off of a liquid line temperature. And that liquid line temperature is literally, and you'll see here in just a little bit, that liquid temperature is literally based off of a pressure. We understand through Boyle's law that every time there is a pressure given, there's a temperature that's going to be related to that pressure. So here we are. We're going to now, we started out, we're in that 38 hertz rating. Now we're literally going to drop to the B hertz rating, which is on the 2 and 3 ton, right around the 30 hertz. And the 4 and 5 ton right around the 32 hertz. And we're going to run for that particular staging for 2 minutes. And we're looking at here now this particular hey, what did we do last hour? Where can I be the most economical as far as my next staging? Where did we create a satisfaction of the set point on the controller, the thermostat? And so that's the logic behind this particular 2 minute period. Then we're going to go, you know what? We are here. We went through the 1 minute, we went through the 2 minutes, and now we're into the third stage. And the third stage is going to be the C hertz rating. And here we are between the 40s. So 2 and 3 ton, 4 and 5 ton, we are now at the 40 hertz rating. Staging is done every time the system comes on the 2.0 in the cooling mode. Okay. Now, the 1.0 staging is similar to this. It's a little bit elongated. So that 1 minute may be 2.5. That 2 minutes may be 2.5. And it's just a little bit elongated from the 2.0. The 2.0, it seems like to us, is that it's almost half of the time frame from being, or the allotment time of staging from the time that we get that Y call to the time that we are literally in the 38 hertz to 42 hertz range, so that we can start the process of what the thermostat wants us to do. So when we go to the heating mode, again, a little bit different. For 4.5 years or so, we've always said that the IDS product does not want to have a programmable set thermostat in the heating mode. And you can see here that this is a reason why. What happens here when we go from a off position on the controller to a heating mode on the controller to a heat call out there on the IDS unit, we see here that we have this particular situation, no hertz. We have a fan speed now. We remember that we bring that fan on before we bring the compressor on. And so when we bring the compressor on, we're looking here at 32 hertz, okay? But I want you to see something here. We have a lot of phone calls at this point in time that, oh my gosh, I am in the air conditioning mode, but yet I'm in the heating mode. But I want you to see what happens for 60 seconds. See my reversing valve? It is off. Well, Fred, why do you do that? We chose to do that because the reversing valve is energized by the 24 volts, but it does not get switched or moved by just the 24 volts. It gets moved by the pressure differential inside the pilot tubes or on the each side of the valve itself, and it goes from a high pressure situation and goes over to a low pressure situation. So here we are, we're running for 1 minute, and we're going to then bring on the reversing valve. And when we bring on the reversing valve, now we're in the heat mode. Now we start our E valve being adjusted. Now we look at the fan speed. What are we doing? What's the temperature outside? What is T4 telling us? Is it below 32? Is it above 32? And so at that point in time, we start to capability of adjusting that outdoor fan motor. Take a look at my starting hertz, 32 for 1 minute. Then we went up to 42 for 1 minute. Then we dropped back down to 32 for 1.5 minutes. This particular stage right here, now we're remembering what we did last hour. Now what we're doing here is can we do what we did last hour at this point in time? Can we do it with the same hertz that we're at right now? And then we do that for 90 seconds, and then we go back up to the 42 for another 30 seconds, and then we now can be adjusted to whatever we're looking for. That degree of temperature, that 107 or that 114 number that we chose on SW44, that's what our target would be. So again, those are my steps of operation with the cooling mode and the heating mode with the IDS 2.0. Now, this is the 2.0. Remember that on the cooling mode, the 2.0 was about half the time that the 1.0 was, and it's the same scenario with this. So whatever these numbers are down here, whatever this time period is down here, it's about half the time of the 1.0. So the 1.0 is going to be a longer staging period than the 2.0. A little bit about the crankcase heater. The crankcase heater is nothing more than that device that is plugged into L1 and L2. It is that device that is going to allow the oil to basically start the warming process so that we do not, what the industry calls, a slugging a compressor. We would like for you to always plug in L1 and L2 as soon as you can upon installing the product, especially in the wintertime. Allow that oil that's in that system, allow that to start the process of getting warm so that when we fire this thing up for the very first time, it doesn't have a code slugging effect to that. So your book would say, I think it's 2 hours. Totally understand that may not be possible, but here's the thing. We want you to plug this in as soon as possible. We want that crankcase heater to have the process of getting that oil in there warm. So couple things turn the crankcase heater on. You've got the T5 compressor discharge sensor. You've got it, if it's less than 104 degrees, it's going to come on. If it's less than 104 degrees and the ambient temperature is less than 50, it's going to come on. Or if it's in the standby mode for 4 hours, it's going to come on, okay? If my system is in an active defrost cycle, so we're in the heat mode, we've been running and all of a sudden it goes into a defrost cycle, it will be turned on at that point in time also. And then it basically goes off when the T5, that's that sensor that's on the hot gas discharge line coming out of the compressor, when it reaches above 113, it will be off. So let's talk a little bit about the reversing valve. I understand that you guys know about the reversing valve. You understand about some people would call it a 4-way or a 3-way valve. Totally get it. Understand that I am a B operated reversing valve. We have not had a whole lot of problems or issues with reversing valves. We understand that I have refrigerant coming into the center port, whether we are in a all-time suction line type scenario. This center port is going to allow us the switching mechanism from whether we are in the cooling cycle or the heating cycle. We're moving that valve over there, like we said a while ago, with pressure differential. Remember that if I have a switching mechanism and it's supposed to be switched, there shouldn't be any temperature differential between these two lines. They are the same, basically the same pipe. But if I've got some problems in here and I didn't switch all the way, then there's going to be some temperature differential between what's going on and what should be going on. And so at that point in time, we literally understand that that 3-way valve up there, we understand that two of those lines are going to be basically the same carrier, and one of those is going to be the opposite, high side, low side, if you don't mind, high temperature, low temperature, and the degrees of differential between that particular same pipe. You're probably not looking at a degree and a half or 2 degrees at the most. It's just the same. It's the same tube. One of the things that we have found that when we had a system, I think there was 3 of them down in the southern part of Texas, and the installer was installing. It was summertime, and he was blowing and going, and he turned the system on, and the system would ramp up to its 100% capacity when he pushed the force button, but on its own, the system would not run above 44 hertz. And he put another one in, and it at a different location, it was 44 hertz, and he put another one in, it was 44 hertz. And what we found out that particular week, that we found out that because my system is a B operated reversing valve, I can be an air conditioner if you just give me a Y call and a common. But we would like for you to energize the reversing valve, even in the summertime, to make sure that it fully closes and make sure that it fully opens and it fully closes so that we have the true effect of the cooling capacity. And what happened is his reversing valve has basically was in the what we call the midsection situation, and that particular system would not, or three of them actually, would not ramp up more than 44 hertz. Once we energized the reversing valve, the system ran perfectly and normal, and as far as I know, they're working normal today. On the condenser fan motor, we understand that the 1.0 and the 1.05 ton and the 2.0 3 and 5 tons have a DC type motor. We understand that that particular motor is going to variate. On the 1.0, there's 8 speeds. On the 2.0, there's 10 speeds, and it is going to variate. It's going to go up and down according to not temperature of the air coming out of the grill, but it is going to variate on temperature change of the refrigerant. So what we're looking at here is we're going to get that particular temperature from the refrigerant pressure. Remember that pressure is temperature. And we're looking at whether we need to go down in speed. If my liquid line temperature gets below 86 degrees, we're going to go down in speed. If that temperature gets above 100 degrees, then we're going to go up in speed. If it stays the same temperature-wise between the 86 and the 100, we will keep the current fan speed of that. And each one of the parameter check buttons, I can push it to number 18, and I can see the fan speed. So if it's a 1.0 3-ton unit, BOVA 36, I'm going to have two parameters, high and low. So that number would be either a 4, there's your low speed, or an 8, there's your high speed. On the other ECMs, you'll actually see whatever speed you're going to have identified in that number 18. So it would be either 86 is 258 PSIG, or 100 Fahrenheit is 317 PSIG. So those represent what's going on with that T3 sensor right there. So this is your logic of the and location of the sensors. T5 is that discharge sensor. T4 is your ambient temperature. Anytime that I had L1 and L2 powered to the unit and the unit was not on, what we would call a standby situation, I should be reading the ambient temperature that is located there where the condensing unit is sitting. So this is the 1.0. When the 2.0 came out, we added a sensor on the liquid line, and that sensor is called T3L. And that it is a great add. It's a great upgrade. It allows the serviceman to now get the subcooling reading, what we would call the true reading of the liquid line temperature, so he can now get subcooling without putting a liquid line sensor clamp on the liquid line like he would have to do with the 1.0. So in the 2.0, man, there's a lot of things that you can literally leave in the truck and sit on a bucket and look and push a button and record those parameters and get your diagnostics from that. So suction line gas, that's the big line. Liquid line, refrigerant line. Of course, you've got the dryer somewhere in that liquid line that comes with the unit. It's in it, that liquid line, of course, is always all 3/8. So parameter check on the 2.0 number 7. That is where I'm going to get that T3L number. When I'm looking at head pressure on the system, I can look at my 410A. When my head pressure was to, for some reason, to get over 580 PSIG, my system is going to protect itself and shut down. It is going to reset automatically when that pressure below the 435 range, and at that point in time, there is a error code that is Charlie Edward, and that error code is going to be illuminated on the fault table and also illuminated on the LED screen. For some reason, if my system hits the 5 times P1, which would be, that's the head pressure. So my question to you would be, why would a system have a problem with head pressure and it be 5 times in 150 minutes or 2 hours and 30 seconds or 2 hours and 30 minutes? Well, let's look at the fan motor. We talked about that. Is that fan motor reacting to what it needs to react? Is it stopping at the first stage? Is it on a 1.03 ton? Is it not activated in the high stage? Is it not? Is it problematic going and keeping that refrigerant temperature at that 100-degree mark type thing? So we've got to look at the fan motor. Okay. Of course, you got to look at the dirty coil. Then you may look at restrictions in the refrigerant line. There's a lot of things that are problematic with head pressure in an air conditioning. Then my system goes into the heat pump mode. Now that outdoor unit is the evaporator and the indoor unit is the condenser. Now I have all of those things that are on the inside that's problematic with head pressure. So we're looking at dirty filters. We're looking at lack of airflow. We're looking at somebody's mix match coil that thought that they could get by with being a cheap install, and they put a coil that was not conducive for a heat pump and made myself an air conditioner, and it worked fairly well there. But all of a sudden we turned it into a heat pump, and it doesn't want to push that refrigerant into that little bitty coil or that type of coil that's not conducive for all the refrigerants that's heading its way. So high pressure. Be very careful about the installs. Be very careful about what are we looking at, summertime, wintertime, because the condenser and the evaporator basically switches location. Low pressure. We're looking at a 44 psi differential of low pressure. Anytime my system would see below 44 psi and I'm there for 5 minutes of operation, I am going to start the process. I may get out there and see a P2. The P2 is an indicator that I've got something problematic going on. If that P2 stays there basically for 5 times within that 101 hour and 40 minutes, then we're going to have an H5 fault code. That H5 fault code is going to lock the system out. We'll have to come out, pull the disconnect, basically seeing what's the problem with the low pressure. Low pressure is a restriction. Low pressure is a refrigerant circuit that has gone south on us from a hole in the line or a bad brazing joint, things like that type scenario. So low pressure is the P2 or the H5 on the fault code. So electronic expansion valve, the E valve. Right, I told you earlier that if my E valve is at 360, that's basically its starting place. It can modulate all the way up to the 480 mark. So from 360 to 480. And I literally can push a button and I can see those particular set points. On the 2.0, that button is number 17. And so when I literally can push that parameter check button and see where that E valve is located. That's one of the things that we may want to look at if we're starting thinking that we've got an electronic expansion valve that has an issue. Turn the system off. L1, L2 is power to it. Push the button to number 18 on the 2.0, and let's see what the position of that it is. It is supposed to be 360. So you got to understand that as my system adjusts, that PI, which is nothing more than the pressure. It's the pressure relief type situation that is there. And we're looking at from the discharge temperature of the compressor to the E-valve, and how we're going to monitor this, and how we're trying to create that superheat of the compressor. And we're looking at from the T5 sensor and what's it giving the board. Then we will start to modulate of that particular system based off of your tonnage. So you've got a 3-ton that can be switched to a 2-ton. You've got a 5-ton that can switch to a 4-ton. And so those particular numbers represent what my initiation in the E-valve is going to be doing. And guys, we have not had any major problems with E-valves. We've not a whole lot of problems with TXV valves. The issue is behind installers not dehydrating the refrigerant lines. So we've got to be very, very careful about the process. When the book says pull that thing down into a micron vacuum, we need to pull it down into a micron vacuum. It is no longer a plurge type situation that we may have seen 25, 30 years ago with the R22 and capillary tubes and accurators and things like that. So a very deep vacuum, triple vacuum is great and to dehydrate those refrigerant lines. So let's take a tech call. Okay, let's take a real life tech call. And when I read these particular scenarios to you, I am not degrading anybody. I am not putting anybody to shame. Just looking at the tech call and the process of walking the serviceman through the tech call while the serviceman is on the phone, being capable of reacting to the tech request and that kind of thing. So here we go. Tech support. How can I help you smile today? Serviceman. Yeah. Hey, I got this Bosch unit, and I think I have voltage, but I don't have any LED lights. Those little things down there are not lit up. Nothing is lit up. Tech support. Is it a 1.0 or 2.0? Serviceman. Yeah, it's light brown. Tech support. Let's check the last digits of the model number. Serviceman. Oh, yeah, it says M18. Tech support. Well, that's the 1.0, or what we would call the 18.5 SEER-rated system. Let's check L1 and L2 voltage together, and then let's check them separately to ground, please. Serviceman. Hey, I've got 243 volts together, and it's L1 to ground and L2 to ground is 122 apiece. Tech support. Thanks. But I don't recall getting your name, sir. And the BTU size, is it a 060 or an 036? Serviceman. I'm Jim. They call me Big Jim, by the way. And it's a 036 model. Tech support. Okay, Jim, let's fix this. Now, very carefully, I want you to locate the CN27 Molex plug on the top left-hand side of the control board and unplug it. Remove it from the board. Big Jim. I found CN27 and I have removed it from the board. Tech support. Any lights? Jim. No, sir. Tech support. That's okay, Jim. I want you to go to the far right-hand side of the board and find the CN14. It's the pressure transducer, and please remove it from the board. Jim. I located CN14, the pressure transducer, and it's removed. Still no lights. Tech support. Okay, Jim. On the top right-hand side of the board is the CN22. It's a Molex plug connection for the reversing valve. Please remove it from the board. This is the CN22. Big Jim says, I removed it. and I've got LED lights. They're on. Tech support. The reversing valve is bad. The short is in the circuit that was causing the board lights not to be lit. The three items that we removed are the three items that get power and use a common from the board. When those particular items are basically in a current situation where they are maybe shorted or there's a problem within inside that, a lot of times they will send a signal back, and through that signal, the board basically goes blank. So we will not replace boards because they're just not lit up anymore. Now we have some information that we can remove those three items, and very carefully, by the way. And in removing those three items, we will come to, maybe like this gentleman, Big Jim said, we came to a problem of one of those, and we now have a part that we can replace without just replacing the board. Every time something goes wrong with my unit is not necessarily the board's fault. This ends section 1. Thank you, and I will see you again in section 2. Have a good day.